Hello, welcome to my 20-minute lesson. My name is Mr. Johnson, and I'm going to be talking today about separation techniques and mixtures. I'm just going to share my screen with you, so give me 1 second, pop this up. Okay, so what you should see in front of you now is the title, which is Key Stage 3 Mixtures and Separation Techniques. This is also quite a nice recap of things for Key Stage 4 chemistry, because this is something that does appear in there as well, just not in as much detail as that. So, learning outcomes then. By the end of this lesson, you should be able to identify what make pure and impure samples and classify mixtures, suspensions, and colloids. You should also be able to describe the techniques needed to separate non-soluble solutes from a mixture with examples, and then describe the techniques needed to separate a soluble solute from a mixture with examples. Pure versus impure then. A pure substance is something that contains nothing else but that substance. We often misuse the label. For example, you might have heard of the phrase pure orange juice when referring to concentrated orange juice. But that's not actually a pure substance because you have the orange flavouring mixed with water. A pure substance is only that substance. For example, pure gold contains only gold atoms. There is nothing else mixed in with it. Pure water contains only water molecules. It has no dissolved salts or sugars or anything else mixed in with it. This is my favourite kind of example. I think Lego's brilliant for all this kind of stuff. But you can see on the page, a load of Lego blocks. These have been separated by colour, gold, and by size, 4x2. This is a sample that is pure. They're all the same building block. Impure then. An impure substance is something that contains more than one substance mixed together. For example, rose gold, which you may have heard of, is a kind of pinkish coloured gold, contain gold and copper atoms, which is where it gets its nice red colour from. Salt water contains water molecules and salt molecules mixed together. This example again with the Lego, as you can see, they're all the same size, but this is an impure sample. They've not been separated by colour. There are multiple different colours mixed up in there. This is an impure sample because they're all different building blocks. So, a pure substance can be an element, which is a substance made up of only one type of atom, or it can be a compound. It only contains atoms or molecules of one substance with nothing else whatsoever mixed in with it. Whereas an impure substance can be a mixture of elements, compounds, or elements and compounds. And by this I mean you can have two or more different elements, or two or more different compounds, or you can have a mixture of elements and compounds all together. So what is a mixture then? Well, we've already come across the idea that a mixture contains different substances, but what's important is they're not chemically joined together. That makes them easier to separate. For example, pack of sweets, Skittles. When they're mixed together like this, they're not joined to each other. You can pick them out, you can go for your favourite colour, but if, like me, you have a favourite colour, then you can easily separate them into a pile of that colour, or even, if they're different types of sweets, shape or size. The characteristic you choose is up to you. There are three different types of mixture based on 1, the size of the particles in the mixture, 2, whether or not they dissolve into each other. So let's have a look at the three different types. First one, you'll have all possibly even done this yourself at home sometime, is a suspension. A suspension is a mixture of an insoluble solid. That means something that does not dissolve in water, in a liquid. An example is sand in water. If left over time, even if you add sand in water and stir it, eventually the sand sinks to the bottom of the water. This is true for any suspension, as the solid particles are larger than the liquid particles, and so they fall down under gravity or sink in the liquid because they're heavier. The second type of mixture that we've got is a colloid. Now, colloid can also be a mixture of insoluble solid particles in a liquid or a gas. An example is jelly, which I love, and so I put a picture of here, or even your own blood. If we take the jelly example, the particles that are in the liquid part of the jelly, or even in the liquid part of the blood, do not sink to the bottom over the time. They literally stay suspended in there. This is because they're in an intermediate size. That means that particles of one substance are not heavy enough to sink through the other. They kind of stay floating in between. This is a colloid. The final type is a solution. You've probably seen this, and you've probably done this yourself: sugar in water, salt in water in the school lab. A solution is a mixture of a dissolved or soluble solid or gas, which we call a solute, in a liquid, which we call the solvent. An example is salt dissolved in water. The salt particles break up into particles smaller than the water. It's almost like playing hide and seek. The salt particles are still there, but they've broken up small enough to hide behind the water. So in a daft sense, they're playing hide and seek between the water and you. You can't see them anymore. This makes them invisible then to the naked eye. So the resulting mixture is transparent, which means it's see-through, but it's not always colourless. Sometimes you can have a solution with a colour. For example, copper sulfate is a blue salt. Dissolve it into water, it makes a blue transparent liquid because it does dissolve. This is true for any solution. It will always form a transparent liquid because the solid will dissolve in the solvent. Key terms then: the substance that dissolves in a solution is the solute. The substance it dissolves into is the solvent. Solute plus solvent make a solution. Key features then. This is a quick summary of all three. The type of mixture: suspension. The particle size of the solid compared to the liquid is larger. It doesn't dissolve into the liquid, and its appearance is opaque. That means light can't go through it when you mix it. A colloid has an intermediate particle size. It means it's in between, or roughly around the same size as the liquid. It doesn't dissolve into the liquid, and its appearance is milky and filmy. A good example of a colloid is milk in suspension, as well as the jelly that we said before. Finally, a solution. The particle size of the dissolved solids are smaller than that of the liquid around it, and it does dissolve into liquid because of that, and its appearance is always transparent. So now that we've got these mixtures, we need to talk about how we can separate things out of them, because some of the mixtures that we exist, that we can see, we don't want. For example, if you have salt water and nothing but salt water around you, how can we separate the salt from the water so we can use the water for drinking? This is a separation technique. There are a number of separating techniques we can use to remove one substance from another in a mixture. Sorry, go backward. The technique used depends on the properties of the mixture and if it's classed as a suspension, colloid, or a solution. So let's take a look at the techniques needed to separate non-soluble, that's solutes that don't dissolve, from a mixture with examples. Non-soluble solutes then. We've said already that a suspension contains a mixture of non-soluble solid and a liquid, such as our sand and water. The solid particles are heavier than liquid particles. So in theory, to separate this out, all we need to do is wait. Separate one from the other, just wait for the heavy solid to sink to the bottom. We can then use a pipette or a straw and just draw the liquid from the top. Problem is, this is not very precise, and it's difficult to separate all of the solid from the liquid with a high degree of purity, especially if you want to drink from it. So what we can do is use a different technique. This one's called filtration. Filtration can be used for any suspension. The suspension is poured through filter paper. The filter paper has holes or pores that are big enough for the water to pass through, along with any dissolved solids, but too small to let the solid sand through. It's a bit like trying to pour a jug full of marbles in water through a sieve. The marbles get stuck in the holes and won't pass through, but the water will pass through. The sand gets trapped as a residue in the filter paper, and the water, which we call the filtrate, passes through into the beaker. The substances are now separated, and as long as you've been careful about it, the water should be cleaned of all sand. Evaporation then. Evaporation can be used for a colloid, and it can be used for a solution if you want to recover the solid from it alone. The colloid or solution is poured into an evaporating dish and placed on a tripod over a Bunsen flame. The mixture is heated to boiling, and then the Bunsen is turned off. This is really important. You don't leave the Bunsen on, you heat the mixture to boiling because that's when it's evaporating at its fastest rate. And then you turn the Bunsen off and allow it to just evaporate away the liquid. If the liquid is evaporating away into the liquid you want, this can be collected, and we'll talk about this in a step later on. But what this should leave behind is the solid. Now, the solid will be left behind in a dish. Sometimes, depending on the solid that you're recovering, it can form crystals, and this is called crystallization. An example is in the picture where you can see salt crystals forming in the basin of the evaporating dish. So those are some of the techniques needed to separate non-soluble solutes from a mixture, with some examples. Finally then, describe the techniques needed to separate soluble solutes, that's dissolved solutes, from a mixture, with examples. So, liquid mixtures versus mixtures of soluble solids. A mixture of liquid can be separated if needed. Key idea behind this is if you needed to separate, say, alcohol from water, or if you were working in forensic science and you were investigating whether a drink contained alcohol, so you needed to check it. To do this, we use the difference in the boiling point, or the temperature at which liquid boils, to separate them. If you have a liquid mixture, usually each liquid will have a different boiling point. And so if we heat the mixture up slowly, the first one to boil will be the one with the lowest boiling point, the next one will have the next lowest boiling point, and so on. This method then is called distillation, or separating it based on the boiling point at which it turns into a gas. Distillation can be used to collect the liquid part of a mixture from a solution. So we can use evaporation to collect the solid, and we can use distillation as a whole technique to also collect the liquid. A mixture of soluble solids can be separated if needed. To do this, we need to use the difference in solubility, how easily they dissolve in a liquid like water, of the different substances. So in this case, it might be that we need to investigate what colours are present in a particular ink. This is used often in forensic science when scientists want to check if the ink that has been used to write a note or to write a check, which is kind of promissory note for cash, is the same as the ink that has been recovered from a pen at the crime scene. This method then is called chromatography, and this is one of the techniques we'll also look at. Simple distillation. This is used for a mixture of liquids. Distillation can be used to recover a liquid from a solution or to separate mixtures of liquids. The mixture is poured into a round bottom flask over a blue Bunsen flame. The mixture gets hotter and the first liquid starts to boil at the lowest boiling point. As the liquid boils, the vapor rises and passes through the condenser. Now the condenser is over here, and this condenser has a jacket around it which is filled with cold water. Cold water is pumped in and the warm water that's coming through it passes out. That condenser takes the heat from the gas, cools it down and condenses that gas back into a liquid. And because the condenser is at an angle downwards, those liquid droplets fall down under gravity and collect in the distillate, in the collection flask at the bottom. When the first liquid is collected, we then keep heating to increase the temperature until the next liquid evaporates, and we repeat the collection steps through the condenser. Down here at the bottom, you can see an actual lab setup picture of it, with the Bunsen at the bottom, the round bottom flask containing a mixture of liquids which appear orange, and the condenser leading to a collection flask on the right-hand side of the screen. Each flask that is collected now holds a pure liquid that's been separated from the mixture. Chromatography. Chromatography being how we collect a mixture or separate a mixture of dissolved solids in a solution, for example, coloured inks. You may have done this practical yourself before in class, and so you'll know what I mean, but a piece of filter paper is marked with the line in pencil about 2 centimetres away from the edge. Now we use pencil to mark the start line because we don't want that line to move with the inks and obscure any results that we might get. A spot of the ink is placed on the pencil line and labelled in pencil. So we place the ink that we want to test on the pencil line, and if there's more than one, we might label it ink A, ink B, based on the pens that we're using. The paper is then clipped to a wooden splint or a pencil, and it's placed in a beaker of water. The water should just come underneath the solution spot. It shouldn't rise above it because you don't want the spot to wash out into the water. You want to move it with the paper. The paper is left for a time. Then what we do is take out the paper, and as you can see in the photo at the base of the page, you get a separation of the different coloured inks that make the mixture. Now the reason for this separation is down to the solubility or how easily those particular inks dissolve in water. The inks that dissolve the fastest will move further up the chromatograph, the piece of paper. So in the image that you've got there, you can see at the top there's a blue line. That blue line is made of ink that dissolves faster than, say, the yellow ink at the bottom of the page. This allows then for the mixtures of inks to be separated based on how quickly they dissolve in water and how fast they move up the waterline. And that's our final outcome. Describe the techniques needed to separate soluble solutes from mixture with examples. All that left is for me to say thank you for watching. I hope you have enjoyed listening to this, and yeah, see you next time maybe. Take care.